Hey, it's Mr. Jewell, and you're watching another exciting Math Notes video. Today we're going to be looking at imaginary and complex numbers, which will be section 2.2.2 in your book. So, imaginary numbers, what are they? Well, pretty simple actually. They're not actually that difficult, as scary as they look. So, an imaginary number, I, is defined as the square root of -1. That is the basis for all of this. I equals the square root of -1. So now if you remember your exponent rules, you can more or less figure the rest out, but let's go through it. Therefore, I squared is equal to 1, because if we square a square root, so we say I is equal to the square root of -1, and we square both the sides, well, on the left we get I squared, and on the right we square a square root and we get -1. So I squared equals -1. And the two solutions of the equation x squared plus 1 equals 0 are I and -I. Well, why is that? Let's see. So we're going to subtract 1 from each side to solve this equation, and we get x squared equals -1. To solve for x, we take the square root of both sides, and we have a square root of -1. So that's x equals plus or minus square root of -1. And we just said that I equaled the square root of -1. Therefore, x is equal to plus or minus I, which is what this line says right here, okay? So let's keep going. The collection or set of 0 and all positive and negative numbers are referred to as real numbers. Essentially every type of number you've dealt with up till now is a real number. So fractions, square roots, non-terminating decimals, everything you know is a real number. Multiplying the imaginary number I by every possible real number except for 0 yields the set of all imaginary numbers. If we multiply by 0, we get 0, which is a real number, so that would be outside the imaginary set. Okay? Imaginary numbers are not positive, negative, or 0. They're imaginary numbers. They're a separate thing. They solve equations in the form of x squared equals a negative real number. So, in general, imaginary numbers follow the rules of real number arithmetic. The sum of any two imaginary numbers is an imaginary number unless it's 0. So, as a little example, 2i plus 3i equals 5i. Okay, we're going to treat that just like another variable. So that's 5 times the square root of -1. The sum of real numbers other than 0 and imaginary numbers such as 2 plus I is neither real nor imaginary. Numbers such as these are called complex numbers and can be written in the form of a plus bi, where a and b are real numbers. Each complex number has a real component, real, and an imaginary component, imaginary. So over here, the 2 is real. It's the real part of that complex number. That is the imaginary part of the number. Imaginary. Okay? The real numbers are considered to be complex numbers with b equal to 0. Okay, so I could take any number, like 4, and say that I could rewrite that as 4 plus 0i, because again, 0 times any number gives you 0, so that's just 4. So that's what that last bit there is saying. All right? So, imaginary numbers. There you go. Let's take a look at what I have for you to do. You're going to have to use your noggin a little bit. Think about these. Tell me what you get. So on the left-hand side it says complete the following. We have I to the 0 power. Remember what happens when you raise something to a 0 power. All right? I to the first power. I to the second power. I to the third power. See if you can complete what those equal. Okay? Start with what you know. Build on it. See if you can complete that table all the way up to I to the 10th power. Then I have a challenge part for you. Using that table, you went from I to the 0 up to I to the 10th. See if you can tell me what I to the 231st power is. Okay? And let me know how you know that and any patterns you find and all that good stuff. And I'll see you guys in class.